On 15th of February 1982, a North Atlantic storm battered the Ocean Ranger while it worked far offshore on the Grand Banks. The rig was the largest semi-submersible drilling unit of its kind, designed and equipped to remain stable through severe offshore weather. Yet before daylight, the Ocean Ranger had capsized beneath the Atlantic, and every one of the 84 men aboard was lost. The central question was not whether the storm was violent, but why one damaged control room became fatal. This is the structural autopsy of the Ocean Ranger. Delivered in 1976, the Ocean Ranger was a self-propelled, semi-submersible mobile offshore drilling unit. By November 1980, it had moved to the Grand Banks to drill the Hibernia oil field for Mobil Oil of Canada. Its size and semi-submersible design allowed it to work far offshore, while the working platform remained elevated above two submerged pontoons. The Ocean Ranger appeared to embody the confidence of a rapidly expanding offshore industry. Its stability depended on controlled quantities of seawater moving between ballast tanks located inside the rig's two submerged pontoons. Electrically controlled valves and pumps shifted that water between compartments to manage the rig's trim, list, and overall buoyancy. The crew monitored valve positions and operated the system through a mimic board located inside the ballast control room. No detailed operating manual was available on board for diagnosing a serious ballast control emergency. During the evening of 14th of February, wind and seas intensified around the rig as the winter storm crossed the Grand Banks. At approximately 19:15, a large wave struck the Ocean Ranger high enough to reach the ballast control room portlight. The impact shattered the ballast control room portlight and sent seawater directly across the electrical control console and mimic board. Conductive salt water reached electrical circuits connected to ballast valves and pumps located deep inside the submerged pontoons. What first looked like local damage had compromised the rig's most important stability system. The crew could see the broken portlight and wet console, but not the true condition of every remotely controlled submerged valve. Electrical faults made the mimic board, valve indicators, and ballast controls increasingly unreliable during the developing emergency. The emergency became informational as well as mechanical. The crew could no longer fully trust what the system displayed. The Ocean Ranger began developing a forward list that continued despite the crew's attempts to restore level trim. As the angle increased, weight distribution changed, load shifted forward, and the rig's remaining margin of stability steadily narrowed. Ballast valves may have opened electrically or been misoperated as the crew tried to interpret the damaged system. Instead of restoring level trim, each unsuccessful correction allowed the boat to settle lower. For several hours, the crew worked inside a rig that was becoming increasingly difficult to move through, understand, and control. By approximately 1 a.m. on 15th of February, the Ocean Ranger was listing about 10 to 15 degrees forward in worsening seas. The senior officer issued a mayday and ordered the crew to abandon the rig. Evacuation began in severe wind, freezing spray, darkness, and heavy seas breaking against the already listing rig. The rig's lifeboats were inaccessible or unusable under the extreme angle, wave action, and weather conditions. Survival equipment offered limited protection once men entered the winter Atlantic. The emergency systems intended for the final escape could not provide a reliable route off the rig. Standby vessels and helicopters attempted to respond while the rig continued losing stability in darkness and heavy seas. The nearest standby ship was 8 miles away, and it reached the scene only after the evacuation attempt had already begun. By then, rescue forces were facing a capsized darkness and seas their equipment was not designed to overcome. When daylight returned over the Grand Banks, the Ocean Ranger had disappeared beneath the Atlantic, leaving only wreckage and debris. All 84 men aboard had been lost. News reached St. John's, and federal and provincial authorities established a royal commission on 17th of March 1982. Its task was to determine why a rig built for the Grand Banks had become unrecoverable after one wave strike. The wreck lay more than 100 meters below the surface. With no survivors available to testify, investigators relied on radio traffic, engineering drawings, equipment records, tests, and recovered physical evidence. They reconstructed the developing emergency step by step, from the first wave impact to the final irreversible loss of buoyancy. The inquiry examined design, training, operating procedures, evacuation, rescue capability, and regulation. The evidence pointed to a chain of failures rather than a single overwhelming event. The shattered portlight exposed the ballast control console, mimic board, switches, and electrical circuits directly to seawater. Shorted electrical circuits could alter ballast valve states while simultaneously corrupting the crew's only displayed view of those states. Operators were therefore responding to a system whose actual configuration was uncertain. The loss of trustworthy information prevented confident diagnosis at the moment precision mattered most. Routine ballast operation did not prepare the crew for a combined emergency involving flooding, electrical faults, unreliable indicators, and uncertain valve positions. The Commission found that a detailed operating manual explaining the ballast system and abnormal emergency response was not available on board. A complex emergency had reached men without the documentation or training needed to reverse it confidently. As the bow settled progressively lower, waves and seawater reached openings leading into the forward chain lockers. Those forward spaces were not watertight, so every additional volume flooded removed buoyancy from the part of the rig already sitting deepest. More flooding increased the forward list, which exposed the lockers to still more water. The emergency had become self-reinforcing and progressively harder to reverse. A wave broke the port light, seawater damaged the ballast console, and reliable control awareness was lost. The rig developed a forward list as ballast actions failed to restore stability. Progressive flooding of the forward chain lockers then overwhelmed the remaining buoyancy. The storm initiated the sequence, but design, control, training, and flooding made it unrecoverable. The Royal Commission examined failures extending far beyond the damaged port light and the electrical ballast control console. It identified weaknesses in evacuation equipment, rescue readiness, crew preparation, system documentation, and regulatory oversight. The disaster showed that supply vessels and transport helicopters could not simply be treated as dedicated rescue assets. The Ocean Ranger was therefore judged as a failure of the wider offshore safety system. After the disaster, Canada strengthened offshore training, emergency planning, equipment requirements, rescue expectations, and regulatory oversight. Ballast control procedures and abnormal situation training received greater attention. Rescue planning placed more emphasis on dedicated capability, cold water survival, and coordinated response. Modern crews now rehearse emergencies that the Ocean Ranger's crew faced with limited guidance. The lasting lesson was that resilience depends on every safety layer working when normal operation ends. The Ocean Ranger entered the storm as the largest semi-submersible drilling rig of its type, then operating anywhere in the world. Its scale and capability suggested strength, but size could not replace protected controls, trained crews, and reliable evacuation. The inquiry demonstrated how separate weaknesses can align into one irreversible sequence. Confidence describes how a system appears. Resilience describes what remains when that system is damaged. Case: Ocean Ranger disaster, Grand Banks of Newfoundland, 15 on February 1982. The rig capsized and all 84 men aboard were lost. Primary mechanism: a storm wave shattered the port light, flooded the electrical ballast console, and disrupted reliable control of the rig's stability system. Progressive failure: the growing forward list exposed non-watertight chain lockers, allowing progressive flooding to remove further buoyancy and deepen the list. Contributing failures: inadequate system guidance, limited abnormal emergency training, unusable lifeboat evacuation systems, and rescue capability unsuited to the conditions. Human consequence: every one of the 84 men aboard died before effective rescue could reach and recover them from the freezing Atlantic. Final finding: the Ocean Ranger was not lost to one wave, but to the chain of failures that followed it.